Hello and welcome to this instruction on solving polynomial equations. Um, we need to go back a little bit and set up why this is an issue and why it deserves its own section. If we were way back in and had something like x plus 5x minus 14 equals 0, we had this problem right here. And had this problem right here, x squared plus 5x minus 14 equals 0. They look an awful lot alike, completely similar in a lot of different ways. They both have a 14, they both have three terms, but they're not even in the same world when it comes to solving. Show you what I mean. Back here, this was a chapter 2 problem. This is one that has linear equations. You take x plus 5x, that's 6x, add the 14 over, you get 14 over there, divide by 6, and you get x equals 14, 6. Or reduce it down, you get 7/3. And you get one answer, and you're good, set, good to go. This is where it's a problem. The first step here was to add like terms, so the x's could be obtained by getting them by themselves. And that was crucial to the entire process, was that the x's had to be able to be got together. You'll notice right here, x squared plus 5x, they are not like terms. And many people have tried various ways of doing this, dividing everything by an x to get that guy gone. Well, then you get divided by x on a 14 and you have an x over here, and you still can't combine like terms. It's just they aren't alike, so you can't put them together. Based on everything we did in chapter 2, chapter 3, chapter 4, everything we've done up until now in algebra, this equation is possible, but as soon as you get a polynomial where you have some degree greater than 1, it's now absolutely impossible to solve with this method, with the chapter 2 way of solving. So we have to go back to the drawing board and find another way to solve equations. So we'll come to this problem in just a moment, but this is how we're going to do it. We're going to go way back to the beginning. We're going to remind you of your 0 times tables. That's right. 3 times 0, what is that? 0. 7 times 0, what is that? 0. Oh, good. You do remember your 0 times tables. In fact, you might even remember the joy you felt when you realized that they all had the exact same answer. And you took something like negative 371 times 0, and it equaled, that's right, 0. You know all your 0 times tables. Not only that, you're able to go backwards with 0. If I have something like 3 times x equals 0, and this is multiplication right over here, you know what that number has to be. You don't even need to divide by that. There's only one number that allows you to multiply to 0, and that is x equals 0. If you want to think about the 3 being divided off, that's marvelous. I'll show you how it works. Well, let's do another one. If you had 7 times y equals 0, what does y have to equal? Oh, it better be a 0. Do you see how nice it is that it makes this chunk, this piece that we don't know, 0? In fact, we can use this for even a little bit more intense problem. If we had something like 3 times x plus 5 equals 0, back in chapter 2 we would have done this. Oh, that's 3x plus 15 equals 0, 3x equals a negative 15, and x equals a negative 5. Oh, good. Okay, so that's how we got an answer. But watch how this 0 multiplication is actually a little bit easier. So if we had this problem and we said, look, this is 3 times something has to equal 0. Well, based on this idea over here, this x plus 5 has to equal the 0. Do you see how nice it is to take just that chunk and say this has to equal 0, and you get x equals a negative 5. In fact, I could do this with something like 7,921 pi over the square root of 17 times x minus 4 has to equal 0. And you could jump that in, 792 pi over the square root of 17x minus yuck. Or you realize this is just a number times something must equal 0. So we produce this equation and say, hey, x minus 4 has to equal 0. That will give us an equation and gives us x equals 4. Isn't that amazing? This is absolutely cool to be able to do this. And now you'll notice what's really happening. Multiplication to equal 0, if we can turn the thing on the left-hand side into something full of factors equal to 0, then we can easily produce an answer. For example, what if I had something like x minus 2 times, say, x plus 7 equals 0? Well, we would get an answer, because this is multiplication to 0, we would get an answer if we made this guy, x minus 2, equals 0. Really? X equals 2? Well, stick it in both places, and you get 2 minus 2 is 0 times 9. 0 times 9 is 0, yeah. Well, what if we made this other guy 0? X plus 7 equals 0. X equals a negative 7. Yeah, look at that. Stick that in, you get negative 9 times 0, still get 0. You actually have two answers. Well, guess what we have just done? We have found the way to solve. Because of multiplication with 0, we now know that we can solve equations if we get them equal 0 and then factor. That's the idea. We make them into factors, and then each piece gets equal to 0, and we get a solution. Yeah, that's all there is to it. So now look at this problem that was absolutely impossible. Can we factor polynomials? Oh, heck yeah, we're good at this. We may have to pull up, if you'll give me just a minute, pull this guy up. This one right here, this was our flow chart that we had. Factoring. Look at this. You remember all of these things? Yeah, everything like here is now in our toolbox, and we are able to use this to solve equations as long as we can factor. That's why this is so important. So getting back to this problem, this one, no greatest common factor, leading coefficient is 1, so we, this is a fast one. And it factors into what times is to a negative 14 and adds to a positive 5. 1 and 14 or 2 and 5. And we get, not 2 and 5, 2 and 7. And we get a positive 7 and a negative 2. So x minus 2, x plus 7 equals 0. Oh, look at this. We've done this down here. If we factored it, now we have this cool multiplication by 0, or with 0. So we can say x minus 2 equals 0, which gives us x equals 2, and x plus 7 equals 0, or x equals a negative 7. We got to check this out. Does this really give us two answers? Let's try it. Stick 2 in here, and we get 2 squared is 4, plus 5 times 2 is 10. 4 plus 10 is 14, minus 14 is 0. Shazam! Let's try it with this one. Negative 49. No, negative 7 squared is a positive 49, plus 5 times a negative 7, that's plus 5 times negative 7 is negative 35. Positive 49 and a negative 35 is 14. Minus 14 is 0. Both of these are answers. And actually, we've talked a lot about degree of polynomials. Well, you've now come to a point where degree means something. The degree of the polynomial is the number of solutions that are possible to give us an answer over here. Fascinating, huh? Two answers that we can have. Let's look at a few more. Here are a couple more for you to see how it works. X squared plus 7x plus 10 equals 0. First step, get it equal to 0. Done. Second step, factor it. This is leading coefficient 1, so this is x, let me see. Multiply to 10, add to 7. That's either a 1 and a 10 or a 2 and a 5. And it's x plus 2, x plus 5 equals 0. Now set each piece equal to 0. So we get x plus 2 equals 0. That gives us x equals a negative 2. There's an answer. And then x plus 5 equals 0. X equals a negative 5. Shazam! Okay, let's try this one right down here. 2x squared minus 13x equals 15. We've got to get it equal to 0. So 2x squared minus 13x minus 15 equals 0. Now to factor, we have to take a times c, which is a negative 30, and then take 1 and 30. Nope, 2 and 15. Oh, that could be. What about 3 and 10? Or 5 and 6. Which one of these is going to add up correctly to it? So they've got to be opposite signs. So it's got to be a negative 15 and a positive 2. So this is 2x squared plus 2x minus 15x minus 15. Grouping now. Chainsaw. 2x, x plus 1, minus 15, x plus 1 equals 0. So this is 2x minus 15 times x plus 1 equals 0. Set each one equal to 0. 2x minus 15. Now you may have thought that, oh, you're just taking the opposite of this number. That's almost true. We take the opposite because when we solve for x, we subtract over. But you'll notice on this one, we're going to add 15 over, and then we're going to divide by 2. So x equals 15 halves. And in this case, x plus 1 equals 0, x equals a negative 1. Yeah, look at that. That's awesome. One more example so you can see how it works with like a difference of squares. If I have x squared minus, or 25x squared minus 36 equals 0. This factors as a difference of squares. 5x minus 6 and 5x plus 6 equals 0. So that'll give us 5x minus 6 equals 0. We're now on step 3 here. So 5x equals 6, x equals 6 over 5, 6/5. And here we have 5x equals a negative 6 when we subtract it over, x equals negative 6/5. And so here are the two answers, and they really will. If you stick them in for x, 25x squared minus 36 will equal 0. Good, now it's time for you to try it on your own. To the boards! All right, here are some problems to head to the boards with. Some polynomial equations. Here are the steps on each one to remind you. Go ahead and give them a try. Press pause. And when you're ready to resume, go ahead and push play. Alrighty, welcome back. I hope those went okay for you. Number 1, 2x squared plus 18x equals 0. We are already got it equal to 0. So now we got to factor it. First step is greatest common factor. Pull out a 2 and an x is what it looks like, and we get x plus 9 equals 0. Set each piece equal to 0. 2x equals 0. Does that give us an answer? Yeah, x equals 0. Right on. X plus 9, the other piece, equal to 0. And we get x equals a negative 9. And yeah, you can check these. Stick in a 0. 2 times 0 squared is 0, plus 18 times 0 is 0. And it works. 2 times a negative 9 squared, so 2 times a positive 81 is 162. Plus 18 times a negative 9, that will indeed be negative 162. And add those together, and you get 0. All right, number 2. 25x squared equals 49. Step number 1, get it equal to 0. So subtract 49 from both sides. And we have 25x squared minus 49 equals 0. The next step, factoring. We've got to look at this. Are there any greatest common factors we can pull out? That's got 5 and 5, and that's a 7, 7. I don't see anything common. So how many terms does it have? It has 2 terms. And a minus sign in between them. And this is a square and a square. Yeah, this is a difference. Woohoo! That minus sign saved us. Difference of squares. So we can factor it. And we have a 5x and a 5x and a plus 7 and a minus 7 equals 0. Okay, so now it's factored. Difference of squares. And then we set each piece equal to 0. So 5x plus 7 equals 0. Subtract 7. 5x equals a negative 7. X equals a negative 7/5. That's one answer. And then 5x minus 7 equals 0. Add 7 over. 5x equals 7 and x equals 7/5. Alrighty, those are the two answers. Positive and negative 7/5. Alright, number 3. 6x squared plus 4 equals 11x. Can you imagine this is a word problem? 6 times a number squared plus 4 equals 11 times the original number. It's impossible. But look at it with math. I love it. So 6x squared plus 4 equals 11x. Getting it equal to 0, let's subtract 11x from both sides. And these terms, the easiest will be to write them in descending order so they look like everything we've been factoring. Equals 0. All right, do we have a common factor? That's step number 1. No. How many terms? 3. Leading coefficient is 6. It is not a perfect square, so we don't get to use that cute little shortcut. We'll have to use the AC method, which is 6 times 4 is 24, which could be 1 times 24, 2 times 12, 3 times 8, or 4 times 6. And it looks like a 3 and an 8 are the ones that are going to work. This is negative, so it'll have to be negative 3 and negative 8. Let's double check. Negative 3 times negative 8 is a positive 24. And negative 3 and a negative 8 is adding to a negative 11. So that is where the negative 11 came from. 6x squared minus 3x minus 8x plus 4 equals 0. We now have 1, 2, 3, 4 terms. Chainsaw, cut that guy in half. What can we pull out of the first half? A 3x. And we get 2x minus 1. And out of this next half, 8 and a 4, we can pull out that sign and the 4. And we're left with 2x minus 1. Indeed, when we pull out a negative 4 from positive 4, we're left with a negative 1. So pull out that 2x minus 1, and we've got 3x minus 4 equals 0. Excellent. So factoring is sometimes the longest part of these problems, but now that we have it factored, each piece equal to 0. So 2x minus 1 equals 0, and that add 1 to both sides and divide by 2. X equals 1/2. On this one, 3x minus 4 equals 0. Add 4. And x equals 4/3. So it turns out if you stick these in for x, these are the two numbers in the entire universe that will fit this equation. Nice job. Notice that the pattern here, always getting the opposite of the negative, negative 9 for a 9, is really the opposite over that leading coefficient. So here you could have done the opposite of negative 1 over 2 and the opposite of negative 4 over 3, which is the same as solving those small little equations down at the bottom. All right, and the last one, 5x cubed. Ooh, we got a cubic equation. Minor note, that means we're going to have 3 answers. That's pretty good. Okay, we got to get it equal to 0, which means we've got to subtract 25x squared from both sides. So we get 5x cubed minus 25x squared minus 120x equals 0. So now we factor. Can we pull out a greatest common factor here? Yeah, it looks like 5 and an x will pop out of there. Good. And we're left with x squared minus 5x minus 24 equals 0. Okay, what's left is a trinomial leading coefficient 1. So this is a fast one, as long as we can find these right numbers. So negative 24, same as these numbers over here, 1 and 24, 2 and 12, 3 and 8, 4 and 6. But this is a negative 24, which means one of these guys has to be negative. So which one of these would add up to a negative 5? And it's that one right there. So this is x plus 3. Remember, you could separate that up and do the AC method if you wanted to. But with the leading coefficient 1, that's not necessary. The numbers you find are the ones that go right in here, because you'll have a negative 8x plus 3x will get it there. Oh, good. All right, so that is factoring that step, and each piece equal to 0. So this piece equal to 0, 5x equals 0. Does that give us an answer? Indeed, x equals 0. Now notice it was crucial that this piece had an x to give us an answer. If it was just a 5 out here, you'd have 5 equals 0, no answer from that piece. But this one has an x. It says, yes, if x is 0, you will get an answer. This guy will give you, let's set that equal to 0. And yes, it gives us negative 3. And this one, x minus 8 equals 0, will give us x equals 8. And indeed, look at that. We have 3 answers that work in number 4. Good. Let's look at the next section. Now we get to word problems. Back in chapter 2, there were a myriad of word problems, a whole bunch of them. Here there are going to be fewer. The thing that designates the difference between a chapter 2 word problem and chapter 5 word problem is that chapter 5 will have polynomials when you write their equations. So when you get to this happy math land, you'll simply have a polynomial that you'll need to factor to solve, which means that the variables need to times each other. So you'll only have two different kinds of problems, and that is when formulas are given to you, or if there are specific shapes, which again, the formulas are given to you. One of these is a very famous one, which is a right triangle with an A and a B and a C, and you'll notice this one has polynomial stuff going on here, a squared and a b squared and a c squared. So we'll work out one from each one of these for you, the formulas and the shapes, and specifically from the right triangle, and then let you try some on your own. So here's the first one. The profit of a small company when they make X thingamabobs is P equals 2x squared minus 17x. How many will they need to make to get a profit of $30? Notice the formula is given for us, and all they're doing is asking what X is when P is 30. Now, most word problems are like this, that you've just been taught how to factor to solve equations. So guess what? When you stick the 30 in there, 2x squared minus 17x, should realize you cannot solve this with chapter 2 stuff. You're going to use the new process, which is getting it equal to 0, factoring, and then each piece equaling 0. So subtract 30 from both sides. 0 equals 2x squared minus 17x minus 30. Okay, 2 times negative 30 is negative 60. Now you may think, wait, what are you doing so fast? There is a thought process that you'll go through. You've got to factor this. So this is that whole flow chart. Can you pull out any greatest common factor? No. How many terms? 3. So we're a trinomial. Leading coefficient is a 2. So we're not a perfect square, and we'll have to do the AC method. So that's where we did 2 times a negative 30 is negative 60. All that thought process was in there and will become more and more fluent as you practice. So negative 60, let's factor it. 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. I think that's all the factor pairs. We got to find one that adds up to a negative 17. So it looks like it'll be negative 20 and positive 3. So that's 2x squared minus 20x plus 3x minus 30. And you could have switched those around if you want. Now we have 4 terms. That's grouping, chainsaw. Take the 2x out, and we're left with x minus 10. And take the 3 out, positive 3, and we're left with x minus 10. And now take the x minus 10 out, x minus 10, 2x plus 3. You'll notice this is the hardest part and the longest part of these word problems, and solving is to do the actual factoring. Because once you get it factored, oh, life is happy now. You said each piece equal to 0, so x equals 10. Or, let me see, 2x plus 3 equals 0. 2x equals a negative 3. X equals a negative 3 halves. I don't know what thingamabobs are, but I know you can't make a negative number of them. So that guy, not realistic. So when you come back into the real world, that math thing, even though the number would make a 30 come out here, it doesn't make any sense at all. So the x is indeed 10. So they need to make 10 thingamabobs. All right, let's look at another one. Here's one that has its formula all on its own. A box has a height of 3 inches. Its length is 2 inches longer than its width. If it has a total surface area of 222 inches squared, what are the dimensions? Well, read that again. A box has a height of 3 inches. I'm going to write that down. Its length is 2 inches longer than its width. If it has a total surface area of 222 inches squared, and yeah, that's an area because it's got square inches on it, what are the dimensions? We'll have to look back. Back in chapter 2, we had a whole list of formulas for shapes, and it will appeal to those. So we got a box, which is a rectangular solid. The surface area, you had like 2 height times length plus 2 length times width plus 2 height times width in some order. So you had like the height times the length, that's the top of the box, and the bottom, there's 2 of them, and then the length times the width, those are the sides, and the height times the width are the other sides. So let's see what we got here. So the surface area, that's a 222 equals 2 times h times the length, which is 2 plus w, okay, plus 2lw, which is 2 times the length, which is 2 plus w, times w, plus 2h, which is 3 times w, oh, which is just w. Yes. So you see how that worked? We stuck this everywhere there was an L, almost like, yeah, substitution. And we stuck the H, which was 3, everywhere that was, and we took the 222 and stuck it in. You take all the data, stick it in, and the equation that we end up with, you'll notice, this is 6 jumped in here is 12 plus 6w. When we jump the 2 and the w in, we get plus 4w plus 2w squared. And then this is a plus 6w. So when we simplify this down, we have 222 equals, we got a 2w squared, plus 6 plus 4 is 10, plus 6 is 16w, plus a 12. And this little exponent right here means this is a chapter 5 problem. You cannot solve it by going back to chapter 2 and getting w by itself. You have to factor. So let's get it equal to 0. Subtract 222 from both sides, and we get 2w squared plus 16w minus 210. And then we got to factor it. Can we pull out a greatest common factor? Yep. The 2 pops out. We get a w squared plus 8w minus 105. Good. This one. This is a trinomial, leading coefficient 1. So this is a fast one. What times is to 105 and adds to 8? Oh, negative 105 and adds to 8. 105. Probably not that one. 2. Does 3 go into it? I think 3 goes into it 35 times. 5 goes into it 21 times. 7 goes into it 15 times. And I think that's all of them right there. So this looks like our one. Positive 15 and a negative 7. So we get w minus 7 and w plus 15. And a 2 out there equals 0. So now let's set each piece equal to 0. 2 equals 0? No, that doesn't give us an answer. That's silly. Okay, w minus 7 equals 0. W equals 7. True. True that. Look at that. W equals 7. And w plus 15 equals 0 will give us w equals a negative 15. Again, this right here, you can't have a width of a box be negative 15 inches long. Even though if the length were then negative 13, this whole thing would have worked. That just isn't realistic. So we're going to cross him out. So the height is 3 inches. The width is 7 inches. And then the length would be 2 more than the width, which is 9 inches. Alrighty, that does it for that one. Now let's look at an A, B, and C problem and see how those work. Here it is. It says Jessie is mowing her backyard that is in the shape of a right triangle. So if we have, it's in the shape of a right triangle like this, good. The shortest side, so this guy right here, is 7 meters shorter than the second side. So if this guy is x, and this guy is x minus 7. The hypotenuse, this longest side right here, is 13 meters long. What are the lengths of the two sides? So this is where this has a formula that links these three sides together, and it's this formula right here. A squared plus b squared equals 13 squared. And notice, because of all these squareds, this is indeed a chapter 5 problem. This is one that has to be done by factoring. So we first have to get it equal to 0 and get everything on this side. So let's multiply this out. X squared plus, this is a binomial. Don't you dare say x squared plus 49. This is x squared minus 14x plus 49. And if you have forgotten, this is x minus 7 squared, means timesing it by itself, and that minus sign means you need to distribute completely. Equals 13 squared is 169. Okay, so that's 2x squared minus 14x. Subtract 169 from both sides to make sure we get it equal to 0. And so that is minus 120 equals 0. All right, we're going to factor. Can we pull out a greatest common factor? Yes, we can pull out a 2. Leaves us with x squared minus 7x minus 60 equals 0. What's left is a trinomial, 3 terms. And leading coefficient's 1, so this is a nice fast one. We just have to find the numbers that multiply to negative 60 that will add to a negative 7. 1 and 60. 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. Any of those add to a negative 7? Yeah, if we have a negative 12 and a positive 5, that will give us a negative 7 there. So x plus 5 and x minus 12. And the 2 out in front equals 0. So we factored it. Now each piece equals 0. So 2 equals 0. That's not an x in there, so that one's gone. X equals a negative 5 by x plus 5 equals 0. This doesn't make any sense for x to make that a negative 5. That just doesn't make any sense in the problem. And then this guy, we have x minus 12 equals 0, which gives us x equals a positive 12. So if this guy is a positive 12 meters, then x minus 7, this is a 5 meters there. Now notice the similarity between that number and that number. That is coincidence right now. This is a negative 5. That 5 did not come from this answer. It came from that 12 being the only number that makes sense for the side of a triangle. Negative 5 doesn't make sense for the side of a triangle. And then 12 minus 7. And you can try it. 5 squared plus 12 squared really does equal 13 squared. So the lengths of the sides are 12 meters and 5 meters. And of course the 13 meters on the hypotenuse. Excellent. Now you have a chance to do some on your own. To the boards! Here you go with some problems. Go ahead and write them down. Pause the video, give them a try, see if you can come to the solution with what we've discussed, and then press play when you're ready to resume. Welcome back. Hope you were able to do it. Let's give it a try. So the projected rate of people walking through the gates of an amusement park, I don't know, Disneyland or something. So how many people pass through the gates at a certain number t? T is the number of hours from their opening. So it opens and then kind of goes down a little bit, big huge rush at the beginning, and then spikes back up, big rush at the end when they close. All right, so all of those are words. What we really need, here's the data. Good. N is the rate of people passing through the gates. So that's N. T is the number of hours. Oh, there's an S there. Number of hours from their opening. Okay, so how many hours? That's T when N have 130 people passing through their gates. All right, so 130 equals t squared minus 12t plus 150. So they gave us the formula, so we just need to stick in those in the right thing, and now we're finding t. Notice that this is indeed a chapter 5 word problem. It's a polynomial equation. We got to do it. Step number 1, get it equal to 0. So that would be subtract 130 from both sides, and we get 0 equals t squared minus 12t plus 20. So now factor. Let me see. Any greatest common factor? Nope. How many terms? 1, 2, 3. Leading coefficient 1. So this is a fast one. So this will go t here, and 20. What goes to 20 and adds to 12? 1 and 20, 2 and 10, 3, nope, 4 and 5. So it looks like a 2 and a 10. T minus 2 and t minus 10. Yeah, minus 2 and a minus 10 will times together to give you a positive 20 and add to a negative 12. So we get t equals 2 and t equals 10 by setting each of those pieces, t minus 2 equals 0, and then add 2. So it looks like we have 2 times. How many hours after their opening? 2 hours and 10 hours. And yeah, this is, if you were to graph this thing, it looks a little bit like this. And so it says it starts off right up here at 150 people, and it'll go and it'll hit 130, and then it goes off during the middle of the day when nobody's coming in or out, and then by the time they close, it'll be back up to so many people crunching through the gates at the same time. So we actually have 2 hours and 10 hours, 2 times at when that will happen. All right, number 2, the area of a window is 240 inches. I'm guessing this is a rectangular window if they don't tell us anything about it. Yep, the width of the window and the length of the window. So let's write this. So the width is 7 less than half the length. So 1/2 L. Okay, good. Now area. This is a shape problem. So we have a formula for area. Area is length times W. So we can see what's going on here. We're going to be substituting this right here in for the W. And the 240 will go in for the area. So we get 240 equals L times 1/2 L minus 7. Now, setting this up and using this formula, sticking numbers in, yeah, today we're in happy math land. But now we're not in chapter 2. You can tell because when we distribute that out, we get 1/2 L squared minus 7L. And that is a quadratic equation. We've got to follow the steps given here in chapter 5. So step number 1, get it equal to 0. We've got to use those 0 multiplication tables. 1/2 L squared minus 7 L minus 240. Okay. I don't like that fraction even a little bit. So I'm going to use my special powers. 2 times by 2 everywhere. And let's get rid of that fraction. So we are back to 0 equals L squared minus 14L minus 480. Wow, look at that guy. All right, so we've got to now factor this. 3 terms, no common factor. 3 terms is going to be an easy one. Well, okay, a fast one. It doesn't look like it'll be easy. So it'll be an L here and an L here. And we've got to take negative 480 and break it down. Let's do it. 1 and 480, 2 and 240, 3, oops, 240, 3 and 160 it looks like. 4 and 120, that's 4 times 12 is 48. 5. Does 5 go into that? Yeah, it looks like 5 will go into that 96 times. 6, does 6 go into it? Let me see, double 3 and you get 6, which is 80. Oh yeah, 6 times 80, so that's 8 times 60. And 9, will 9 go into that? I don't think so. 10 will definitely go into it, 48 times. Are we getting closer and closer to 14? Well, if one of these is negative, that's 38 is a difference there. 12 will go into it 40 times. Sheesh. 16 will go into it 30 times. Oh, I think we're getting closer. 24 will do it. Let me see. 16, 18, 20 will go into it 24 times. So with one of these being negative and they add to a negative, so the bigger one, let's do these down here. Does anything add to a negative 14? And it's this guy right here. So L plus 16 and L minus 30 equals 0. Whew. Factoring is the hardest part. That's why we spent a whole section just on factoring. But we can do it from here. The third step in solving an equation, we had to set it equal to 0, factor it, and then set each piece equal to 0. So we get L plus 16 equals 0 and L minus 30 equals 0. And this is L equals negative 16 and L equals 30. We have 2 options, and when you're drawing a window, you'll notice that the length being negative 16 inches long is horrible. That doesn't even make any sense. So that guy's gone. Cancel him out. All right, so L equals 30. Good, so the length is 30. And then let's find the width. The width up here is 1/2. Let's write this down. Width is 1/2 of the length, so 30 minus 7. So that's 15 minus 7 equals 8. So we have 30 inches by 8 inches, the length and the width. And does that really have an area of 240? Yes, it does. Whew, that was a toughie. All right, last one. Carl is building a right triangle hot tub. So that means we have this shape going on right here. And remember, we're going to be using, with a right triangle, that gives us a squared plus b squared equals c squared. So a, b, and c. So one leg is 3 feet more than the other. So if this guy's x, then that guy's x plus 3. And the hypotenuse is 15. So a squared plus b squared equals c squared. We've got x squared plus x plus 3 squared equals 15 squared. A right triangle will always use that formula. It's the Pythagorean theorem and genius stuff. Okay, so we get x squared. Notice we're in a polynomial equation. We've got to get it equal to 0. So we've got to multiply these out. Make sure you don't try that freshman's dream. This is going to be x squared plus 6x plus 9. Make sure you know where all of these came from. That's x plus 3 times x plus 3. You must multiply it out because of that plus sign. Equals 225. So that's 2x squared plus 6x minus 225. That gives us a minus 216, I think. Good. Now it's equal to 0. Second step, factor. So take a 2 out, and we've got x squared plus 3x minus 108 equals 0. All righty, x squared plus 3x minus 108. This is now 3 terms. Greatest common factor has been taken out. So this is a fast one. Let's put it up over here. X squared plus 3x minus 108. With the 2. This is going to be a quick one if we can find the right numbers. So negative 108. We have 1 and 108, 2 and 54, 3 and 36, I think, 4 and 27, 5, 6 and 18, and 7, 8, 9, and 12. Oh yeah, it's 9 times 12. We knew that. We knew that. All right, one of them has to be positive and one of them negative. They have to add to a positive 3. So it looks like a positive 12 and a minus 9. There we go. So minus 9 and plus 12 equals 0. Okay, good. We got it factored. So get it equal to 0, factor it, set each piece equal to 0. Here we have 2 equals 0. That's bunk. That's not a real thing. X minus 9 equals 0, x equals 9. And x plus 12 equals 0, x equals a negative 12. That's also junk because you can't have this number be a negative 12. So x equals 9 is the only thing that makes sense for the length of a triangle. So x equals 9 and x plus 3 is 12. And we should note that that 12 is not that 12. The 12 is 3 bigger than what x actually is. So there you have it. Those are the 3 problems. Excellent. Now you'll be ready to do your homework.